Hi, everybody. This is Mike with the National Weather Service in Amarillo, Texas, and I'm here today to talk to you about the fire and severe weather season outlooks for the Texas and Oklahoma panhandles. Here's an outline of what we're going to talk about today. We're going to start off looking at the past rainfall and the influence that that had on the growth of the grass fuels in the area. We'll look at the current state of El Nino and the outlook regarding El Nino. We'll look at the temperature and precipitation outlooks for the spring, summer, and fall. And we will also be looking at the implications of El Nino and the transition to La Nina that we're going to talk about on the spring fire weather and severe weather outlooks. So, as most of you know, we have been in a state of El Nino over the past just shy of a year. And that El Nino and La Nina are referred to as ENSO, or the El Nino Southern Oscillation. And what this is all about is water temperatures in the tropical Pacific Ocean along the equator. And so when you have above normal water temperatures shown on the left with these warm colors along the equator, you have what we call El Nino. And El Nino tends to produce different precipitation patterns across the country, which tend to be more favorable for our part of the world here. And when you have below normal water temperatures, as shown in the cool colors here on the right, you have what we call La Nina, and that also has influence of weather patterns across the world. And so what happens with these is El Nino will have influence on the moisture in the Pacific Ocean, but they also have an influence on where jet streams tend to set up. And that changes precipitation patterns across the country and really across the world. And again, El Nino is more favorable in general for precipitation in this part of the country. La Nina would be less favorable. So we've been in this situation of El Nino, and we've seen the rainfall throughout the winter, at times through the growing season as well. But what we're looking at, and we'll talk about more, is an anticipation that we're actually getting ready to transition directly into a La Nina over the months to come. So when we're looking at the rainfall that we saw in May of 2023, you can see this graph is showing the percent of normal, and most of the Texas and Oklahoma panhandles area in May saw 200%, double or more the rainfall, 300 or more percent in some areas. In fact, some areas from southwest Amarillo to Hereford, Texas, saw upwards of 13 inches of rain in a 30-day period, mainly falling in May. And if you remember, it rained almost every other day. About 17 days, I believe, is what it was measured rainfall at the Amarillo Airport in May. June dried out a little bit for parts of the area, certainly stayed above normal in other parts. But what the combination of these two things really did was set the stage for above normal fuel loading that is developed across the Texas Oklahoma panhandle, as well as into parts of southwest Kansas, southeast Colorado, and western Oklahoma. And so we're going to look at a little more in depth in that. But before we do, we're going to look a little more in depth at the rainfall that occurred. So we're going to look at this in a little different way. This is, again, percent of normal rainfall focused in on the Panhandles region. But on the left, we're looking at April 15th through June 15th, so a 2-month period. And in that time frame, you see, again, 200 to 300, 400% of normal rainfall from mid-April through mid-June. So that really contributed to getting us a kickstart in the grass fields. And if you remember, the previous year we had been in a drought. And so it took a while for this to really kick in and really help get the grass to grow, because we had to get some soil moisture built up. But eventually it definitely took hold. Now, from June 16th to September 15th, much of the area actually turned very dry. And you see it more along the lines of 25 to 50% of normal rainfall across much of New Mexico, West Texas, the southwest 2/3 of the Texas Panhandle. But the area of the northeast Texas Panhandle and western Oklahoma, southwest Kansas, and southeast Colorado continued this wet period through mid-June, through mid-July, and into August. It probably shut off before so we got to September, but so we had a much longer period of above normal rainfall that continued well into the summer in the northeast panhandles. And what this has led to is while the entire area has above normal rainfall because of that very wet May and early part of June that we had, this area has the highest amount of fuel loading because the grass has just continued to grow further along into the summer. So, looking at Texas County in the central Oklahoma Panhandle region, an area north of Optima or east of Guymon, this is a picture from January of 2023 on the left, and then looking at January of 2024 on the right, and the red arrows pointing to a single tree out there as a reference point. But this is the same area, and you see a tremendous difference in the fuel loading that occurred with very little below normal in 2023 coming into the early part of this year, as I referenced, to above normal, as you can see there in 2024. So a significant difference in the fuel going into this fire season than what we saw last year. On the left picture here, we're looking at Hutchinson County, Borger area, still quite a bit above normal fuel loading in that region as well. And then in Potter County on the right, still above normal, but I think you can see not quite the amount of fuel loading as you can see further north, as you move further north, especially in the northern, northeast Texas and, eastern part of the Oklahoma Panhandle. So we went into a drier period that I'm not going to show here, September, October, November, and then from the mid-November through the latter part of mid to latter part of February here, you see that we again went to above normal precipitation with the influence of El Nino finally kicking in December. Now, most of this above normal area that we're seeing here happened with one 3-day rain event, 2 to 3 days, that occurred in December, where the Texas Panhandle saw anywhere from 1 to 2 inches in the southwest of rain, but 3, 4, 5 inches of rain in the eastern part of the region. And that is significantly above normal. And so that led to 200 to 300% above normal for the really almost the entire winter, but really most of that was one rain event. Now, we did have some events beyond that late December, January and February as well, but the majority of it happened early on. And on the right, you can see that's the departure from normal, showing the amount. So anywhere, mostly 2 to 6 inches, some areas maybe a little above 6 inches, but mostly in the 2 to 6 inch above normal rainfall in the area, or snow melt if you were to melt the snow down as well. Again, moving southwest, western Texas, not faring quite as well. So what that has done is that's led to above normal ground moisture in the northeast, especially the northeast panhandles area and parts of western Oklahoma, southern Kansas, seeing above normal ground moisture, and near normal ground moisture as you go southwest of there, and you have to get into far southwest, West Texas, southern New Mexico to see below normal ground moisture. So what this could mean, and we'll have to watch, is historically this is going to help us out to possibly green up sooner. And why that is basically when you already have ground moisture in place, it won't take as much of a rain event to get enough ground moisture when we warm up enough, which is typically in April, maybe late March, April, to start creating a green up. As opposed to last year, we get a half inch of rain when you have almost no ground moisture. That is not going to lead to a green up. If we get a good widespread half inch of rain in April this year, because there's already ground moisture in place, that's much more likely to lead to a green up. And so that could potentially produce an earlier green up than what we saw last year. Last year we didn't green up, well into May, essentially because we were just so dry. We didn't really green up in April last year. So we may see our peak of the fire season be more in March this year. And if we get just, normal rainfall in April, that should lead to a green up. And so maybe we see a shorter season than what we might otherwise. But again, that very much depends on getting some rainfall. If we just shut it off completely, we will not green up. We do need some rainfall. It just won't take as much as normal. So looking at the drought monitor, most of New Mexico is kind of in the center of the worst drought conditions in parts of West Texas, and especially in southern New Mexico. There is some area of abnormally dry D0 condition in parts of this far southwest Texas panhandle. But most of the area is not showing much of a drought category, which is good to see. But you don't have to go far into the you don't have to go very far west into New Mexico to start seeing moderate and severe drought start showing up. So this is a look at the water temperatures. Once again, this is mid to late January through mid to late February. The warm colors again showing above normal water temperature. You see it's not a super strong signal, and you can see signs of this being not as much above normal as you look at this loop going into February. But that area circled in red is an indication of continued above normal water, suggesting a weakening El Nino potentially, just based on that picture there. El Nino is generally measured in this box here. I'll show it again on the next slide. But this box is called the Nino 3.4 zone. And that is usually where you measure the strength of these events. But we are influenced east of that, more toward the coast of Central and South America as well. Now, if you look at this from a little different perspective, this graph, the top of the graph is showing surface water temperature. And as you move down in the graph, you're looking deeper in the ocean. So this is a cross section looking at that area right along the equator. And so what you notice in this loop is these below normal water temperatures starting to show up in the deeper water, 100 to 200 meters down, and slowly working its way up closer and closer to the surface. So this is a common way that El Nino or La Nina, in this case La Nina, potentially will show itself deeper water first, and that works its way closer to the surface. So that is an indication of things to come. So now we're looking at a graph here of ENSO, and we're seeing the water temperature in that 3.4 zone. This is the average water temperature. So you see we're running about 1.5 degrees or a little more above normal in that water temperature as we went into January. Now, for El Nino and La Nina, we measure these water temperatures in the average water temperature, and we measure it in 3-month increments. So you see on the bottom of this graph, this NDJ, that was November, December, January, and then you can see just January listed there. But then JFM, that's referring to January, February, March. And so by the time you get into the spring, late spring, MJJ, that's May, June, July, so like late spring going into summer, forecasting a neutral condition. And by the time we get to mid to late summer, and especially by the time we get to fall, you can see that the forecast, and this is basically a bunch of different model forecasts, all these different lines are the model forecast of the water temperature, showing most of them indicating La Nina developing. So on the bottom right here, you can see the probabilities of La Nina really increasing by the time we get to June, July, August. So basically by the end of the summer, forecasting 55% chance of La Nina forming. And as you get into the fall, over 70% chance of being in a La Nina condition. And because of that, the Climate Prediction Center has, even though we still are in an El Nino advisory, has actually issued a La Nina watch for the anticipation that a La Nina will be forming. So above that, you can see the Nino zones, and I was talking about that 3.4 zone in the middle, but there is a Nino 3 and a Nino 4 combination of the two gives you Nino 3.4, and one other box, that Nino 1+2 box. But again, that Nino 3.4 box is where the strength of these events is measured, generally speaking. So want to talk a little bit about the influence of ENSO or El Nino and La Nina on the fire weather season here. And El Nino generally leads to a split in the jet stream, but a more southern storm track that produces more moisture and more chance of rain with the southern storm track in the Panhandle area. All of these systems have a moist part and then this dry air intrusion that tends to come along the southern end of it. So when we're in El Nino, you generally get more of the moist part of these systems, and that dry air is more in Mexico and in parts in the West Texas that comes in on the south end of these. So El Nino generally promotes more southern storm tracks and better moisture across the panhandles. La Nina tends to promote a more northern track of these storms. And again, it's just on average that you get this more often than not. It doesn't mean that all of them are. But La Nina, you tend to get this more northern storm track. So the better moisture tends to be further north into the plains. And you notice, Oklahoma, central Oklahoma kind of does better and, does okay in both situations. But the Texas and Oklahoma panhandles tend to be more on the dry side of these. So La Nina generally promotes slightly more northern storm track, and that tends to lead to more days with drier intrusion and strong wind. So our fire weather generally is much worse in La Nina springs than in El Nino springs, and the moisture is less, and we generally again do better with the moisture in El Nino. So we're looking at the near-term outlook here, again with the keeping in mind that we're in this transition, right? We're going to be in this transition toward neutral and eventually La Nina. It is kind of interesting that the above normal precipitation, the better chances of seeing above normal precipitation, again, that's just a probability of that. It doesn't mean for sure you're going to be above normal, but just a better probability tilting the odds. That's really more showing up more north of the area. We're in the Texas and Oklahoma Panhandle are more in a region of seeing equal chances. So about a 33% chance of above normal, a 33% chance of below normal, a 33% chance of near normal in the Texas and Oklahoma Panhandle. The interesting thing about that is that looks a little more like a La Nina storm track that we were showing here on the previous slide. Uh, if you look at that. So we'll see how that goes. There has been some indications, I will say, though, as you go into April, that we may have one last hurrah of maybe a little wetter pattern developing in April. So we'll hope for that. Certainly near normal would be a good thing for this region as well. But for now, we're seeing equal chances for the most part in precipitation and temperature as well for the month of March. So yeah, as mentioned, that kind of looks a little more like a La Nina pattern as far as the storm track goes. So we'll see how that goes. Now, when we look at severe implications for this region, Texas and Oklahoma panhandles, it is interesting that when you look at years, we average about 17, 18 tornadoes a year in the Texas and Oklahoma panhandles combined. So when you look at years where we had 25 or more tornadoes, notice that a big majority, over 50 or 55% of those were either we were in El Nino in the spring, or we were in El Nino in the winter and we were in the process of transitioning toward La Nina, which is what we're really expecting for this year. So we are in a part of uh, this pattern that has a little better probability of seeing above normal tornadoes in the Texas and Oklahoma panhandles. Now, I will say, I think it's important to state, and this is specifically referencing the Texas and Oklahoma panhandles. Uh, if you were to look at like central Oklahoma and eastern Oklahoma, those areas actually tend to have more tornadoes in La Nina. So not very far away, but the very different impact of El Nino and La Nina versus your tornado potential. So I just wanted to point that out. You don't have to move very far east, and it's actually the opposite of this. But for the Texas and Oklahoma panhandles, you notice that only 11% of the busy tornado years were La Nina. So we'll see what that means for next year. But for this year, we're in this El Nino to La Nina transition. Now, another way to look at this, going back since 1990, this is a trace of the water temperature in that 3.4 zone. Looking at actually the oceanic Nino index, it's not just water temperature. But one thing I have pointed out in this graphic, all of the transition years where we were in a moderate El Nino and we transitioned either to neutral, like in 91, 92, or we transitioned to a La Nina, like we did in 97, 98, and then going into 98, 99. But you notice that in these transition years, there's been 6 moderate events since 1990, and 5 out of the 6 of these experienced above normal tornadoes. And 3 of them were significantly above, and 2 of them were just slightly above, 19 and 22, 19 and 91, 92, 22, and 2002, 2003. But the other 3, uh, quite a bit above normal on these transition years. Now, if you include, we didn't quite hit moderate in 2007. It fell just short of reaching a moderate level event. But that year we just fell short, and we had 58 tornadoes. So if you include 2007 in this mix, you're talking 6 out of 7. Now, I will point out that notice 97, 98, we only had 2 tornadoes in the Texas and Oklahoma panhandles. So while this tilts the odds, being in a transition year tilts the odds towards above normal tornadoes in the area, it is no guarantee. And I also will point out that when I looked back a little bit prior to 1990, it wasn't as quite as a strong signal. There were certainly transition years that we did not have above normal tornadoes. But I do think it's important to point out that for the Texas and Oklahoma panhandles, a transition spring increases the potential for having tornadoes in the area. We'll see how that goes. So the rest of the spring, if you look at March, April, May, we're looking at equal chances for temperatures of above or below normal. And we're also looking at equal chances for above or below normal precipitation. So it looks like it's really going to be difficult to say, and that's that influence of that transition at work there. If you look at Amarillo specifically, again, as I pointed out earlier, equal chances in this case just means there's no strong tilting of the odds towards in temperatures above or below normal, and the same as far as precipitation. Just basically a 33% chance of above normal, 3% chance of a below normal, and in this case for precipitation, a 34% chance of near normal precipitation. So there's not a real strong tilting of the odds one way or the other, despite the fact that, like I said, there is a suggestion of a tilting of the odds towards potentially above normal tornado season in this region. Going ahead to the summer, as we get stronger into most likely La Nina taking hold, notice in this case, we see above normal temperatures. If we're below normal in rainfall in the summer, that usually means we're above normal in temperatures. And little concerning, this area of below normal precipitation showing a 40 to 50% chance of below normal precipitation, really focused on the Texas and Oklahoma panhandle and parts of West Texas. And here's the actual probabilities in Amarillo, so showing a 44% chance. Now, I will say that while we have a 44% chance of that occurring, looking back at transition years, there are some transition years that 1 month in the summer ended up being relatively wet and helped bring us up, kind of to a near normal summer. So it's certainly not a complete given, but the odds are tilted towards the influence of La Nina starting to impact us and having below normal rainfall for the summer. And as we go into fall, I'm going to be curious to see how this might change, because El Nino or La Nina is anticipated to be, really kind of peaking as we go into the fall of 2024. And right now, the climate models are suggesting equal chances as far as rainfall goes. It definitely has a pretty good signal to above normal temperatures for the fall. But I would wonder if we may see this change as we get closer. We may see this area of below normal precipitation. We'll see if those chances end up expanding more into the plains as we move forward in time, and the probabilities of La Nina. We get a little better understanding of how the La Nina may go. So just kind of to summarize things, we are seeing El Nino pattern. We anticipate that we may see the influence of that continue through the early part of spring, maybe not March as we looked at, but we'll see how that goes. But we do expect a relatively rapid transition out of El Nino through the summer, and increasing odds for below normal precipitation and above normal temperatures due to the influence of La Nina forming. And again, that La Nina formation chances actually 60%, and now is going up as we get later in time to 70% chance or more chance of La Nina forming. So kind of what we're watching more, uh, with with respect to the severe weather season, again, just summarizing historically, the Panhandles area observes a higher number of tornadoes. We have more chance of above normal tornado season when we're in either in El Nino, but in this case, in this transition from El Nino to La Nina. Again, it's not a given, but we have seen, uh, you know, 5 out of the last 6 times that we've had a moderate El Nino that we had above normal tornado season. But if we transition quick enough into La Nina, that certainly could preclude that from happening. Fire weather wise, uh, potentially fewer high end events, uh, and fewer high end fire weather days if we remain more in a El Nino pattern. But this does not mean that we're going to see no days or that we won't see an outbreak. That just means there's less chances of higher end days generally. Now, the caveat to that though is, as we showed, we have significantly more fuel. So when we have high end fire weather days, we have more potential to burn more acreage because there's just a lot more fuel out there than last year. So we're looking at a possible peak maybe more in March than in April. Again, this assumes that we are made if we can maintain a normal rainfall pattern. Now we'll have our dry spells that will lead to fire weather potential. We always have that every spring. But if we can get just a little bit of rain as we go into April, because of the ground moisture, we have a little better chance to green up and maybe not see this very long season. Now, if the rain does not develop, then certainly we're gonna have to go back on that. But we'll look at maybe March being the peak this year. That's traditionally been what's happened in years where we were transitioning or we were in El Nino. The peak was more in March, and then we kind of came out of that. But we'll have to see how that goes. Now, because of that earlier start, or because of the onset of La Nina and potentially a drier summer and especially a drier fall, that would suggest potential of an earlier start to next season. Uh, so we could have and an overall higher frequency of higher end events next season. So maybe an earlier start. Some years we don't see much of a fall fire weather season. We may have a better potential of a little more busy fall next year if we get in this drier pattern, and certainly more higher end days next fall, and or especially in the spring. But the question is going to be, what are the fuels going to look like if we are really dry this summer and we graze down? What's been out there. It'll be interesting to see what happens there. So the fuel part of that's going to be a little uncertain until we see what happens this summer. But on the weather end of it, you would think there'd be more potential for higher end fire weather days next season and potentially an earlier start. So again, the big caveat here is how quickly do we transition from El Nino to La Nina? Does it happen so fast that really precludes some of what is above here, and that is a possibility. And we'll have to see how that goes. And then there's always, how fast does the atmosphere respond? There's a little lag to the atmosphere responding to El Nino developing or La Nina developing at times. So we'll see how that goes. So that is all that I have. Hopefully, that answers some of your questions about what we're looking for as far as El Nino and La Nina and the implications that will have on the fire weather and severe seasons. I appreciate you watching, and by all means, if you have any questions, would feel free to contact us at the National Weather Service, and we would be happy to answer those.